Hey guys, I'm Yu Liu, a PhD student from the University of Sheffield, Department of Civil and Structural Engineering. The topic of my project is ductile connections to improve structural robustness in fire. Connection failures observed in the collapse of the World Trade Center and the Caddington full-scale fire tests indicate that connections are potentially the weakest part of a structure. Typical connection failures are shown in the figures, including fracture of end plate, net strut stripping end plate, and bolt shear in fin plate. At the initial stage of a fire event, the thermal expansion of beam will generate compressive force on connections, and the attached column will therefore be pushed out. When the temperature rises to a high level, continual reaction of beam occurs, and the forces of connections change to tension. And finally, connection fractures resulting in the collapse of the attached floor and the buckling of columns. Fire may spread to other compartments. This has the capacity to cause a disproportionate collapse of an entire building. The figure shown here is based on the research work conducted by the University of Manchester. It is adjusted bit for steel beam. The red curve in this figure shows a change of internal force of an end plate connection during a fire event, including the thermal contraction of the beam superposes tensile force on the connection. But connection with more ductility can potentially reduce the actual force generated in the connected beam, as presented by the blue curve. In order to improve the ductility of connections to enhance the robustness of structures in fire, a novel ductile connection shown in the figure has been proposed. This ductile connection consists of two identical parts, and each part can be manufactured by deforming a steel plate. Each part takes the form of a fin plate, a face plate, and a semi-cylindrical section. The function of the cylindrical section is to provide additional axial push-pull ductility by allowing the fin plate to move away from and towards a face plate. Up to now, our research work on the performance of the ductile connection includes experiments on model scale specimens, development of analytical models based on simple plastic theory, development of component-based models, and frame analysis using Vulkan and Abacus. This is a deformation of the novel ductile connection with the increase of temperature. At low temperatures, compressive force generated on the connection. When the temperature is over 700 degrees, the deformation of connection becomes pulling and tensile forces generated on the connection. This figure also shows the excellent deformation capacity of the ductile connection. Comparative results between the frame with the ductile connections and thin frame with other types of connections are shown in the figure. As can be seen from the figure that the actual force of the beam with ductile connection is significantly reduced compared with the beams with other connections. This indicates that the proposed ductile connection has more ductility to accommodate the actual deformation of the beam in fire. Thank you guys for watching this video. If you have any questions, please do not hesitate to contact me.